I got here an hour or so ago, and it's the first time I've heard the system, and it's the first time I've heard, I think it's the first time I've heard any of the NAGRA reference. I've heard some of the NAGRA HD and then lots of the little classic stuff. And I have to say, it's spectacular. I was blown away. First of all, this is an amazing room. But what the NAGRA ref stuff is doing is not like anything I've ever heard. There's I told, I don't know if Renee is in here. No, he's not. For me, it was a layer of sort of infinite detail that I have never heard from solid state. It's the kind of thing that you can get from really good tubes in a way. It's like the sound is not made up of little parts. It's a continuous thing. It's the way you hear in nature. And this is the first solid state I've heard do that. Just a stunning system. It's the bane of my existence as a speaker maker that the speakers are the least expensive component in this whole system. But it is typical. I mean, for 25 years, that's sort of often been the case. These speakers are very closely related to another model I have, the O96, which they're right out there. Exactly the same external dimensions. Drivers are in the exact same spot. If you took a black and white photo of the two speakers and made a 3D model of them and rotated them, the port tubes are in the exact same spot. The stands are the same height. What they are, and actually if you do the same thing with the O reference, which is the model above this, you would actually see the same thing. There's a few differences on the ref, but the main tweeter, the main driver, where the port tubes are, the size and height and dimensions of the front baffle, identical. So it's one of the things that makes my speakers unusual in the market. Most speakers in the market are sort of more typically a very narrow speaker. Generally, the dimensions of the front baffle are kind of like vacuum formed to wherever the edge of the woofers are. Sort of the widest driver, that's going to sort of dictate the edge of the cabinet. And I make speakers like that. When I first started 25 years ago, all of our models followed that same kind of recipe. But 15 years ago, I wanted to make a speaker that was higher sensitivity so that you could use it with lower power. And I wanted to make it friendly to the kind of amp. There's a sort of an exotic style of tube amplifier called single-ended, and what it means is that there's a single device, a single tube, providing all of the power for each speaker. So one tube powering that speaker, one tube powering that speaker. And what makes that kind of a circuit very dependent on the speakers that it's driving. It's very, very influenced by the speaker itself. No amplifier. An amplifier is not a complete circuit unless there's a speaker attached to it, or an 8 ohm resistor or something like that. If you disconnect this speaker, that's not a complete circuit. The circuit incorporates the speaker and the speaker load, drivers, the crossover, the tuning of the cabinet. That's all directly connected to all of the circuitry in an amplifier. And the influence of that is more or less noticeable depending on the kind of amplifier technology. So 15 years ago, I wanted to make a pair of speakers that would work with sort of a really broad array of amplifier styles, including these little exotic low-powered tube amps. And so doing the research, I began to realize, so first of all, in order to make it higher sensitivity, I knew I was going to need to use a larger woofer. In order to make it not have a negative influence on the way that these exotic little amplifiers sounded, I needed to keep it a two-way. A two-way meaning only two active drivers, one tweeter, one woofer, and that's it. There's no mid-range, there's there's not multiple woofers or anything like that. And I realized that in order to keep those amplifiers sounding as good as they can, to keep them sort of as happy as possible, it had to be a two-way. So that started to dictate the shape of the speaker. To to have high sensitivity, we have a big woofer. Has to be a two-way, so the woofer can't be on the side or on the bottom or anything like that. So the front of the speaker starts to grow. And so as I started prototyping, I realized that there were a lot of benefits to a wider speaker, not just that it will hold a bigger woofer. It adds to the sensitivity in other ways. So the sound coming off of a speaker, everything except for the lowest bass is coming directly from the drivers, directly from the tweeter and the whatever cone drivers or planar speaker. It's coming directly from the front. It's launching from the speaker surface. And so if you're launching from a really narrow speaker, it's coming this way, and as the frequencies get lower, as the notes get lower, the wavelengths get wider. And as the wavelengths get wider than the front of the speaker, the pattern of those waves launching into the room starts to curve around the sides of the speaker. So the width, the size and width of the front of the speaker controls where that wraparound starts. When the frequencies start to wrap around the speaker, the sensitivity of the speaker drops. It's putting less energy into the room, less energy towards the listener. And there's a mathematical way to describe it, but essentially what it's doing is it's going from the sound coming out in a hemisphere to the sound coming out in a sphere. So you lose a percentage of the energy into the room. So by pushing the wavelength lower, where it starts to lose that energy, I've essentially increased, even though anechoically I didn't increase it, but in room to a listener in front of the speakers, I've increased the sensitivity in that way as well. Another thing is, so the ear is very sensitive in certain ranges, so the human vocal range, things like that. So mid-range and upper mid-range, the ear is extremely sensitive to not just kind of the tonality, but it's also sensitive to really, really tiny details like spatial information, timing delays, things like that. So by pushing the frequency where that wraparound happens out of that really, really sensitive range of the human ear, it improves other things other than sensitivity, and it makes the speakers behave in a way that is more natural feeling to a listener in a room. There's been a myth, so skinny speakers sort of started to become the style in the late 80s and all through the 90s. It was kind of like that was the new thing. And the way that they were sold is that skinny speakers, to get a really precise imaging, you needed to have narrow speakers because the reflections on the front of the speaker would interfere, and you have to have this dispersion thing. And it's not really true. There's, like a lot of sales pitches, there are elements of truth in there, but there are also one of the things that happens is all of a sudden speakers went from looking maybe sort of like this to looking narrower. The way the speakers sounded changed in that same way because they were losing sensitivity in the mid-range and in the bass. They all started to sound a little bit brighter, a little bit more detailed because you're actually changing the tonal balance of the speaker. You're not adding detail, but you're emphasizing treble in a way. And so, you could sort of map that out as well. Listen, it's more precise in the imaging. But my point is that was all sort of an illusion. And there are good things about narrow baffles and things like that, but in the context of what I was trying to achieve with these, none of those were relevant. So 15 years ago, I designed the O96, the first model in this range. And there's a few tricks. So for everyone who's been listening already, you'll notice that first of all, they do image quite well in here. The other thing is that the speakers are quite low, so when you're in the listening position, your ears are above the top of the cabinet, and that's designed that way on purpose. The tweeter is very close to the top of the cabinet, and that allows them to actually image significantly above the level of the speaker. So a lot of times when people first sit down in front of these, they're trying to scrunch down really low in the chair and trying to get on their ears down here, but actually they're not going to sound as good with your ears down here. They're lined for this, and that's involved in what's called polar tilt. So we're talking about that hemisphere of sound wave launching out. You want that sound wave launching out to be coherent. You want your ears to feel like that sound wave is coming from a single source. And that is done by positioning the drivers in space. So the depth of that tweeter horn, the depth of the woofer, the relationship of those to the listening position, that's all done with the design of the drivers and in the crossover itself. It was sort of when I first got the 96 dialed in and ready to release as a product, a sort of a magical thing happened. All of my dealers, they looked at pictures of it and they were like, don't send us any, there's no way, none of my customers are into that retro shit. We don't want old-fashioned sounding speakers here. So I was just like, look, buy a pair of demos, I'll give you a 100% refund towards a different model, don't worry about it, there's no risk. And they started finally, trickling into the stores, and 100% of the stores were just like, they're just like, send us more. People are ordering them. People come in, they're looking at all the speakers, and they look at those, and they're like, wow, what are those? I want to hear those. So it's just sort of like, it was a phenomenon, and they started figuring out ways to make systems that imaged in rooms that they never had good imaging in before. Just sort of like throwing it's like a new way to sort of to bring people into the fold. This speaker and the O96 are identical in every externally physical way. So the drivers are in the exact same position where the dome is, where the ports are in the back. The idea is to keep that exact same sort of magic of the O96, but try to get as much out of that recipe as I possibly can. So even though it's the same template as an O96, every single element in the speaker is different from what's in an O96. The actual textile of the dome is the same, and the actual paper cone is the same, but everything around it, the horn obviously is a machined bronze horn, voice coil in there, magnet, a machined bronze phase plug versus the cast plastic one, different voice coil on this. The port tubes in the back are bronze. They're isolated from the back, so the lowest bass frequencies in a ported speaker come out of the port. So the port tubes have a ton of acoustic energy coming out of them. And in most speakers, the port tubes are connected to the cabinet. And they're transferring a ton of energy to the cabinet walls, and the cabinet walls are the largest radiating surface on any speaker. The surface of this cabinet is much larger than the surface of that woofer. So the cabinet only has to vibrate a little bit to contribute a lot to the overall sound. So by basically casting the woofers out of bronze instead of using ABS plastic in those, we've increased the mass 10 times, and they're isolated. They're floating in the cabinet. They're not touching the back baffle at all. And we've reduced the effect of the cabinet on the overall sound in the room by 15 or 18 dB. The other thing, I'm just sort of rambling. This is my first pitch here of the night. I'll be smoother later on. Another thing I wanted to touch on is people say that you can't get good imaging because the woofer's so big. How can you have a two-way with such a difference in the sizes of the drivers. The O96, when it was measured by Paul Miller in one of the biggest hi-fi magazines in the UK, and it was one of the lowest distortion speakers he'd ever measured. One of the other advantages of a large woofer is that it doesn't have to move as much. So in a two-way, when the woofer has to do the lowest bass and it has to get all the mid-range all the way up to where the tweeter starts to operate, the requirements of the low bass means it has to move a lot. The requirements of the mid-range means it has to move very, very quickly. And those two things are really quite in conflict with one another. Even if you have a woofer that can move an enormous amount and very quickly at the same time, you will still always have some type of distortion. If you have a tiny woofer producing bass moving a ton, it's going to be producing intermodulation, but also Doppler. So Doppler distortion is when you hear a siren on a car that's zooming by and it changes pitch. Right? That's the sound waves as it's moving towards you are one pitch, as it's moving away from you, it's another pitch. So if you have mid-range coming at you from a cone that's also doing bass and going like this, it's another form of distortion. So the more of those distortions you can pull away, again, the more natural the wave launch is going to be from the speaker, and the more, for me, it's like how can you listen to the music and not think that you're listening to a hi-fi, and how can we make that as easy as possible? And you want your brain to have to work as little as possible to filter out the idea that you're listening to a record. You want it to just affect you like you're listening to real music, a real event in real space. And so just all of these small details, that's all towards that end. I think that's most of it.